So today we will discuss about how to estimate mean precipitation with the help of Isohyetal method. As already discussed, there are three most common methods for estimating mean precipitation of a watershed from the different rainfall as measured by the different gauge stations available in that watershed. So is uh, this is what we know as Isohyetal method. Now, before beginning, let us explain what is isohyetal lines. So the isohyetal lines is that line which connects the points which have equal precipitation. Suppose in a watershed there are different gauge stations, correct? Now, if I filter out those gauge stations which has measured today's rainfall as 5 millimeter, then we can draw a curved line within the watershed like this. So in this line, the precipitation as measured by the gauge points or gauge station is same. That means 5 millimeter. Similarly, there can be another line which connects those points which have a precipitation of 4 millimeter, and so like this. So generally what happens if this is the watershed, then the isohyetal lines are like this generally, and this line represents one precipitation, this line represents another precipitation, this is another, this is another. You can note that this P1 and P2 is bordering interhyetal area. The area bordered by interhyetal lines is known as interhyetal area. So this is that area. This area is bordered by the line which represents the precipitation P1 and P2. Similarly, for P2 and P3 is engulfing this area or bordering this area, and then P3 and P4 bordering this area, and so on. And here also you have to begin from 0 to 1 to 2 to 3 to 4 to n. Correct? So to find the mean precipitation of this entire watershed, you have to apply this formula. A1, this is the interhyetal area between P1 and P2, multiplied by P1 plus P2 divided by 2. So this, if this is area 1 as bordered by P1 and P2, then this will be A1 multiplied by P1 by P2 divided by 2. Okay, plus A3 multiplied by P2 plus P3. That means A3, if this is the area A3, and this is the P2 and P3, then this will be A3 multiplied by P2 plus P3 divided by 2, and so on, and An minus 1 into Pn minus 1 plus Pn. So as you can see that if this is P1 and P2 and this is A1, then you multiply A1 into P1 plus P2 by 2. This is 1. Plus, then you go to the next one, P2 and P3, and this will be your A3. So this A3 multiplied by P2 plus P3. You note that whatever number of gauge station or whatever number of precipitation, this area is before that precipitation. That means, let it be very clear, P1 and P2 both borders this area A1. Okay, but P2 and P3, it is bordered by the area A3. So I think here there is a mistake. This is not bordered by A3, but it is bordered by A2. And P3 for P4, A3. P4 and Pn, this area will be An minus 1. So whatever subscript is there, this area will be minus 1. Correct? So if this is 0 and 1, this area will be 0. Again I am saying P1, P2, this is P2 minus 1, A1. So area bordered by P1 and P2 will be named as A1. Area bordered by P2 and P3 will be named as A2. Area bordered by P3 and P4 will be A3. Area bordered by P4 and Pn, suppose this is Pn, will be An minus 1. Correct? And area bordered by 0 to P1 will be A0 because P1 minus 1 is 0. So A0. That is why what happened is, in here, if this is Pn, this will be Pan minus 1. And this will be Pn minus 1, certainly, because if this is 3, this will be 2, because this P2 and P3 is bordering the A2. Okay. So in this way, we will name the precipitation as well as the area bordered by them. The formula is like this. I have already discussed, and this will also be 2. And this will be your P, mean precipitation. So let us take some numerical example of estimating mean precipitation of a watershed with the help of Isohyetal lines. So this is the estimate Pm if the area and precipitation of the Isohyetal lines is as given below. So here you see P0 is given, P1 is given, P2 is given, P3 is given, P4 is given, P5 is given, P6 is given. Correct? And also P7 is given. And this area is also given, that is the area which is bordered by P0 and P1 is A0, then A1 bordered by P1 and P2, then A2 bordered by P2 and P3, and so on, as we have already explained. So P0, P1 is bordering A0, P1 and P2 is bordering A1, P2 and P3 is bordering A2, P3 and P4 is bordering A3, P4 and P5 is bordering A4, P5 and P6 is bordering A5, and P6 and P7 is bordering A6, and so on. So we'll calculate up to A5, that means the area which has been bordered by P4 and P5 and P6, up to this we'll calculate. So the values are given, the precipitation and area values. As you know, the formula is also given, A0 into P0 plus P1 by 2, then plus A1 into P1 plus P2 by 2, like this. So what happens is, you just put values. What is the value of A0? 0 square meter. We have taken area square meter, precipitation in millimeter. So A0 is 0. So this entire term gets 0 because anything multiplied by 0 is 0. So let us come into the next part. A1 multiplied by P1 plus P2 by 2. A1 multiplied by P1 plus P2 by 2. As you see, if this is P2, this will be A1 because P1 and P2 is engulfing A1. Similarly, if this is P3, this will be A2 because P2 and P3 is engulfing or bordering A2. So the value of A1 is given, A1 is 2, so this will be 2, and P1 is 5, so 5, P1 is 5, P2 is 7, that's 7, so 5 plus 7 by 2, that is 12, 5 plus 7 is 12, divided by 2 will be 6. Now this is 6 millimeter, this is square meter, right? So you will keep it as this of 2 into 6 plus, you know what is area 1, area 1 is given, it is 2, area 1 is given, so it is 2. Sorry, we have already calculated area 1, so we are going to A2. So A2 is given, it is 3, and this area A2 is bordered by P2 and P3. So P2 is 7, P3 is 8, 7 plus 8, 15 by 2 is 7.5. Then come to the next one, that means this A3, correct? A3 is given as, where is A3? 5, so 5. And A3 is being bordered by P3 and P4. P3 is 8 millimeter, P4 is 12 millimeter. 8 plus 12 is 20, divided by 2 is 10. Keep it like this. Next, come to the next one. That means A4. A4 is bordered by P4 and P5. P4 is 12, P5 is 18. 12 and 18, 30. 12, 18, 12 plus 18, 30. 30 divided by 2 is 15. And it is multiplied by 7.5 because area A4 is given as 7.5. So 7.5 into 15, keep it as it is. We will come into this part. Then let us go to the area 5. Area 5. This is area 5. A5 is given as 12. So this is your 12 multiplied by A5 is engulfed by or bordered by P4 and P5 and P6. So P5 is 18, P6 is 21, correct? So 18 and 21 is 39. You divide by 2, it will come 19.5, correct? Now you note that these are this is in square meter, correct? These are all in millimeters, correct? These all areas are in square meter, and all precipitations are millimeter, correct? But you know that this entire summation from let us take something else. This entire summation from here to here, correct, will be as per formula divided by the total area of the watershed, and that total area of the watershed will also be in square meter. So if you take common the square meter unit, then you can divide it, uh, then you can deduct it with the help of the denominator. Because if you see, this is what I am saying, n, this is summation Pn minus 1 by Pn, and this is, sorry, n minus 1. Now this is being, this will be divided by 2, this is the summation, n is 1 to n, or letter. So this is the formula of this entire expression is shortened into this part, correct? An minus 1 multiplied by Pn minus 1, so this will plus Pn divided by 2, okay? So if n is equal to 3, this will be 3, this will be 2, and this will be 2, 3, this will be 2, 2, 2, 2, so on. We are adding all these things. Now this entire thing is divided by the total area, that means An summation. Now you see this part, the unit of this part is square meter. Unit of this part is square meter. So you can deduct it out, cancel out. So whatever it remains is millimeter. Correct? As I am estimating mean precipitation, and the unit of precipitation is millimeter. So the resultant unit here is also millimeter. So it satisfies the dimension laws. So what we do is we can actually multiply this area term with this precipitation term, and these will be the results. All of these will be the results. Correct? So what we'll do is we will add all these things, 0 plus 12 plus 22.5 plus 50 plus 112.5 plus 234. This entire term will be added now. Let me see what the term from. So this will be your 0 plus 12 plus 22.5 plus 50 plus 112.5 plus 234. And this is the end. Correct? Yes, this is the end. This is 431. It is coming up to 431. Now you divide it by the total area. Total area means from 0 up to 12. Correct? Yeah. So 0 plus 2, 2, 2 plus 3, 5, 5 plus 5, 10, 70.5. This will be 29.5. 7.5 plus 12, 29.5. So this will be divided by 29.5. Let us see what is 29.5. So let's say 4, 3, 1 divided 4, 3, 1 divided by 29.5. So it's coming 14.61. So the mean precipitation will be 14.61 millimeter. It is actually coming 14.610 lots of term. But 14.61 is okay. You take 2 digit after decimal, that is enough. 14.610, so we have taken 14.61. If it was 14.619, then we would have taken 14.62 as per the round off rule. Anything above the 0.5, you round it up to the next higher digit. Anything below the 0.5, you round it up to the lower digits. So as you know, if it so as you know that if I take this as 14.529 as and I will take up to 2 digit after decimal, so I can take this as this will be 14.53 as it is 14.52. Correct? If it is 14.521 or 522, then you can keep it as 14.52. This is actually the round off rule of the how to round up a long fraction of this digit. That is what is the rule. Okay, so now let us summarize the entire process. So our problem was estimating mean precipitation if the precipitation or the precipitation measured by the gauges is represented by isohyetal lines and the area bordered by those isohyetal lines are provided. This is the technique known as the Isohyetal method of estimating mean precipitation. So here the precipitation can be like this. In this line, precipitation is set. In this line, precipitation is set. So if this is P1, this is P2, this is P3, this is PM, or not PM, this is PM. We have to estimate PM, mean precipitation. And so what happens, in between these lines there is an area. So P1, P2 will border the area A1, P2, P3 will border the area A2, P3, P4 or Pn will border the area A minus 1. The formula for estimating PM or mean precipitation is like this. It is the summation of An minus 1 multiplied by Pn minus 1 plus Pn divided by 2 divided by the total area. Correct? This is your mean formula of mean precipitation. So in the numerical problem, P1, P2, P3 and all these P's will be provided. Interhyetal areas will be provided. All you have to do is you have to apply this formula and find the mean precipitation. Remember, don't get into the problems of unit conflicts, as area is in square unit and precipitation is a length unit or a depth unit. So always remember that, because these two units are different, but as the square unit, this numerator is divided by the total area in the denominator, and the total area has a unit of square unit also. So these two square units will deduct out, and what will remain is the depth unit of precipitation. So that is why as mean precipitation that we are calculating, and the unit of mean precipitation will also be a depth unit, maybe in millimeter, maybe in centimeter, and the resultant unit of this expression, this entire expression, will also be a depth unit, correct, or millimeter or centimeter, like this. So this type of problems are very easy to solve. You will be provided all the P's bordering these areas and also the area. You will just apply this formula and find out the mean precipitation. Thank you.